Okay, the next topic I will discuss is dynamic memory allocation in C language. Okay, so before I am going to explain dynamic memory allocation, I would like to explain what is meant by static memory allocation. So static memory allocation means it is the allocation of some amount of space at compilation time by the compiler. Okay, so the static memory allocation process is going to allocate some amount of space. Okay, who is going to allocate the space here? It is the responsibility of C language compiler to allocate some amount of space according to user requirement at the time of compilation. So once the space is allocated by the compiler in static memory allocation methodology, that is fixed. Okay, that is fixed means that cannot be altered. It cannot be either decreased or increased. Suppose I will declare one array like this, integer a of 15. A of 15. Now a of 15 means that it is the responsibility of a compiler to allocate how much space here. Suppose integer variable occupies 2 bytes. 2 into 15, it is going to occupy 30 bytes of space. 30 bytes of space. So 30 bytes of space we may or may not used. We may or may not be using this space. Suppose like this here, it is going to allocate 15 cells like this. Here each and every location is going to occupy 2 bytes of space. 2 bytes of space. And 2 bytes of space is occupied for each and every location. And total amount of space is required for this array is what? 30 bytes. So once I declared A of 15 means that is fixed. Suppose after declaration of this array, I want to accommodate few more elements. Is it possible? It is not possible. It is highly impossible because once the size is declared in static memory allocation, that is fixed. That cannot be altered in any cost. Okay. Suppose I want to increase. Okay, that is also not possible in the static memory allocation because once memory is allocated means that is fixed. That is fixed. Okay. The drawback of static memory allocation is what? Wastage of space is occurred. Wastage of space is occurred. That means in advance we have to declare some amount of space. So if you are not using that much space, if you are using less number, what happens here? The space allocated in the advance, that will be wasted because that cannot be altered. Okay. So in case of static memory allocation, what happens here? The memory either it cannot be decreased or increased here. Okay. I have declared 15. So after that I realized that the memory is not sufficient. I want to accommodate 5 more elements. Okay. So if you want to allocate 5 more elements, it is not possible. That is fixed only. Okay. So the drawback of this static memory allocation is what? Wastage of space is occurred and the performance of the application is also reduced. The performance of the application is also reduced. Okay. So that is a primary drawback. So in order to overcome this process in C language, we have a sophisticated technology, a efficient technology that is called as dynamic memory allocation. So in the dynamic memory allocation, the memory is not allocated at compilation time. So the memory is allocated at runtime. At runtime, the memory is allocated. Okay, so that what happens here? You need not to waste any space. The space will not be wasted. The space will be efficiently used. The space in the memory space is efficiently used because you are allocating space at runtime. At runtime. Static memory allocation, that is just like advance booking. Suppose I have reserved 10 tickets for a particular train. So if I may not use 10 tickets, okay, suppose I have used only 2 tickets. In such case, what happens here? 8 tickets will be wasted because in the very advance we are reserving the tickets. So at the time of traveling, you may not use all those tickets. If you are using only 2 tickets, what happens here? 8 tickets will be wasted. That is what? Advance reservation. That is compilation, reservation, compilation, allocation. Now in case of dynamic memory allocation, while traveling only, you are going to reserve the tickets. Okay? That is best efficient usage of the tickets. So in that method, what happens here? No tickets will be wasted because as per the requirement only we are going to take the tickets. Okay, that is Current reservation is dynamic memory allocation. Advanced reservation is static memory allocation. Okay. So how to achieve dynamic memory allocation in C language? So in order to achieve dynamic memory allocation in C language, we are going to have 4 functions. So what are the 4 functions here? malloc function, next calloc function, realloc function and free function. 4 functions are there. So what are the syntaxes and what are the usages of these 4 functions? Just I will discuss. So when coming to malloc function, malloc stands for memory allocation. So memory allocation function is going to take how many bytes here? So memory allocation function is going to take only one parameter. So what is the one parameter here? malloc byte size. How much space you require for this array? For this block. So look at this syntax here. PTR means PTR equal to cast type. Cast type means suppose I want to reserve space for integers. I want to reserve space for integers. So the integer type must be mentioned over there. So if I want to reserve space for floating point numbers, floating type must be, that means the type must be converted to floating type. So that is called as what? Cast type. Cast type. Suppose I want to allocate number of bytes for long variables. So in such case the cast type must be long. malloc byte size. How many bytes you wanted to assign? And next when coming to second example. So what is the second example? calloc function. Especially calloc function is used for allocating space for arrays. Calloc stands for contiguous allocation. Contiguous allocation. So it is going to allocate some number of blocks in sequential fashion which are a fixed type. Which are fixed size. Suppose I want to allocate like this. A of 15. A of 15 means what happens here? So like this similar kind of 15 elements will be allocated side by side in contiguous fashion. In contiguous fashion the memory is allocated. So C stands for contiguous allocation. So next function is what? Realloc function. So realloc function, especially this is for modifying the previously allocated space. Suppose previously I have allocated 20 bytes of space. After I feel that I don't want this much of space, just I require only 10 bytes of space, or I want to increase the size 30 bytes. So in such case I can use realloc function. So realloc function is going to take 2 parameters, pointer and new size. Your old size is 20, the new size can be either 10 or 30 bytes. The same way calloc function is going to take 2 parameters. N means how many elements you wanted to allocate and what is the size of each element. What is the size of each element. And the next last function is free function. So once you assign the allocate the space, finally that means at the end of the application it is your responsibility to deallocate the space. So if the deallocation is not there, what happens here? The space will not be released. So in case of Java language, what happens here? Automatically the space is deallocated by the garbage collector. Okay, a special kind of software is there in garbage collector whose responsibility is to deallocate space which is allocated at runtime. Okay, automatically the space is deallocated by the garbage collector entity. Now here in C and C++, it is a responsibility of programmer, developer to release the space, to deallocate the space which is allocated by these 3 functions, malloc, calloc or realloc functions. Okay, so this is about dynamic memory allocation in C language. Using these 3 functions, we can implement dynamic memory allocations. 3 functions is allocation. 4th function is for deallocation. Okay. First function is malloc function. This is especially for allocation of some a block of space. A block of space. So calloc function, it is for allocating space in contiguous fashion. Contiguous fashion means for array elements. Array elements are having fixed bytes. Okay, for array elements, like for array elements, you can use calloc function. Next, realloc function, especially this is for changing, this is for altering the previously allocated space. And free function, especially this is for deallocation of the space, which is allocated by these 3 functions. Okay. These are syntaxes. For example, PTR equal to cache type is integer, malloc. So here I want to assign bytes. Here you can say size of you can say 10, means 10 bytes of space will be allocated at runtime. Second one, PTR equal to int star calloc contiguous allocation, and 10 comma size of, you can say size of int, means what happens here, size of int means it is going to give 2, means 10 into 2, 20 bytes of space will be allocated for this. Third example, PTR equal to integer star, here the no casting is required for reallocation. Reallocation, you can say this is suppose PTR1, this is PTR2, and PTR2 and new size. Here how much size is allocated here? 10 comma 10 into 2, 20 bytes. Just I want to change the size like this. Previously I have allocated 20 bytes, so this time I am allocating how many bytes here? 10 bytes. I have altered the size. And if you want to free the space, you can use this fourth function, free PTR. This is suppose PTR4. You can use PTR4. This is about malloc, calloc, realloc and free functions examples. So look at the examples and dynamic memory allocation functions. That is, I will show malloc, calloc, realloc and free functions examples. Just you have a look here. So in the first program I am going to implement malloc function. So this program intention is to ask how many numbers the user wanted to enter. So those many numbers will be read from keyboard. For the user given numbers, what happens here? It is going to calculate sum. Okay, just to look at the screen here. Integer n comma I star PTR sum equal to 0. Sum is for storing sum of n numbers. N comma I, this is for looping variables. PTR, that is for storing address, starting address of the memory block. So first I am taking user choice, enter number of elements. So the number of elements, the choice is stored in n. So according to user requirement, what I am doing here, PTR equal to the pointer. So the address of starting element will be stored in PTR variable. So the first parameter is casting, type casting. So I want to allocate values for integer variables. I want to allocate blocks for integer variables. Okay, suppose I say 2, so 2 blocks are allocated, 2 into 2, 4 bytes will be allocated for this. So if PTR equal to null, means if PTR is going to return null value, means no memory is allocated, the memory allocation is not successful. Okay, so if PTR is, if malloc is successful, it is going to return the starting location of the bytes. Okay, suppose 4 bytes are allocated from 1890. Okay, so 1890 becomes starting location, so the 1890 will be allocated into PTR. Okay, so PTR equal to null, allocation cannot be done, so we are simply terminating the job. So enter, so if it is not equal to null, memory allocation is succeeded. So when memory allocation is succeeded, what I am doing here, enter elements of array. So I am reading these n elements. For I equal to 0, I is less than n, plus plus I or I plus plus, anything you can say. So if you say I plus plus, some logic will be different here. Scanf percentage d PTR plus I means the elements which are giving will be stored into PTR array. So this is sum calculation, sum equal to sum plus PTR plus I. So like this also you can write, not if you get confused, you can write like this also, sum equal to sum plus star PTR plus I, PTR plus I. Next, finally, what I am doing here? I am printing sum. So as we have discussed in the very beginning class of pointers, so if a pointer variable is placed by star mark, it is going to give value. If it is not placed by, if it is not prefixed by star mark, it is going to indicate what? Address. Okay. So as I have placed star mark, it is going to give value. The value stored at PTR plus ith location. So just look at the execution here. Enter number of elements. Just I want to enter 3 elements. So for 3 elements, space is allocated at runtime. Now it is asking the elements which have to be stored. First element to be stored is suppose 5, second element 7, third element is 8. It is a sum of 5 plus 7 plus 8. 5 plus 7 plus 8 means 20. Okay. So finally what I am doing here, free PTR means the space allocated. How many bytes are allocated in this case? 2 into 3. 6 bytes are allocated. So those 6 bytes will be deallocated. So that will be freed. Okay, this is regarding malloc function. Using malloc function, dynamically we have allocated n bytes, n into size of integer. So n into size of integer means, yes, suppose n is 3, 3 into size of int. 3 into size of int means what happens here? For integer, for every integer variable, it occupies only 2 bytes. Okay, so 2 into 2, 4 bytes is allocated. So if you give 3 bytes, so 3 elements, 2 into 3, 6 bytes will be allocated. So this is about malloc function. In the same way, I will implement calloc function. Just you have a look. Just you have a look of malloc function. So this is the procedure. Next I will discuss calloc function. Calloc. This is calloc function. Calloc function is for allocation of space for contiguous locations. Especially this is for array elements. Okay. So like in last program, first I am taking user choice. How many elements you wanted to enter. Okay. So the user choice is stored in n variable. PTR equal to integer calloc. Calloc function is going to take 2 parameters. First parameter is the number of elements. Second parameter is the size of each element. Means n comma size of int. Suppose I want to enter 2 elements. 2 comma size of 2. Size of int means 2. N into 2. N into 2 means 2 into 2, 4 bytes will be allocated. Again I am checking same condition. If PTR equal to null means the space cannot be allocated. The space cannot be allocated. And if the calloc function is succeeded, it is going to return the starting address of the block. Like this, scanning percentage d PTR plus I. Here also I am performing sum equal to sum plus. If you get confusion, like this also you can write sum equal to sum plus. Here just you remove it. Finally, sum I am printing. Only difference between last application, this application is there I am using malloc, here I am using calloc function. Okay, how many elements you want to enter? Suppose I want to enter 4 elements. 4 elements it is going to ask from user. 45, 55, again 45, 55. 200 is the sum. Sum is 200. This is about calloc function, contiguous allocation. So next I will show realloc function, which is the last function in the dynamic memory allocation implementation. So that also I will show, just you have a look. Just to have a look. So like in last program, I am taking 4 variables here. One is for storing starting location pointer I, n1, comma n2. So enter size of the array. The size is stored in n1 variable. So initially I am using malloc function. Malloc function for allocating space. So n1 into size of int. Suppose n1 is 2 elements. 2 elements I want to enter. 2 into size of int means 2. 2 into 2, 4 bytes will be allocated here. So the details of memory addresses I am printing using this loop. The details of memory addresses, first address and second address. Okay, if the size is 2. The size is 2, address of first element and second element I am printing using this for loop. I equal to 0, I is less than or equal to n1, I plus plus. You can write plus plus also. So this is going to PTR. So this is not prefixed by any star symbol. So it is going to give address PTR plus I. So after once locations are printed, now I am changing the size. So enter new size of the array. Realloc PTR comma n2. This is the new size. So PTR initially stored starting address, and PTR n comma 2 starting from PTR n2 bytes will n2 positions will be allocated. So those locations I am printing here like this. Okay, just to have a look, I will execute this program. Here also you can use, you can remove plus plus. Enter size of the array. Suppose 4 elements I want to enter. These are the sizes of 4 elements. First byte is at 1892. As it is integer type, the next byte will be 1894, 1896, 1898. So these are the addresses of contiguous locations. 4 contiguous locations. Then enter the new size. Suppose this time I want to enter 5 elements. Starting from 1892. 5 elements 92, 94, 96, 98 and 1900. Okay, so this is about new sizes. This is regarding memory allocation in C language. So finally you can use free function and get ch for halting the output.